ISBN is short for International Standard Book Number, which was developed in later 60s for giving each book a unique ID. The original length of the code is 10 digits long. Nowadays, it has been extended to 13 digits, which we're not going to cover in this video. Let's have a look at the structure of this 10 digits. 1 digit represents the language of that book, and then 2 digits represent publishers. Then we have 6 digits, which means 1 million different numbers to be able to assign to each individual book under that publisher. Then finally, this is something we really want to talk about today. It's called check digit. This check digit is specially added in order to identify errors appeared in the code. Without checking digit, all possible 9 ISBN digits, they are all valid. The minimum distance between them is 1. They're all next to each other, right? Our job is to add 1 extra digit to increase minimum distance from 1 to 2. If you recall, we did in previous video, minimum distance must be at least 2 in order to identify single error. It means the check digit must satisfy this condition. Any changes appears in 9 digit, check digit itself also changes, which means 1 change must bring 2 changes within the code. Therefore, minimum distance can be guaranteed as 2. How can we do that? The solution is actually very simple. We add all digits together, then mode them by 10. So it's just like we have a scale, and we have a 2 side of scale. Then any changes happens on the left side and right side also changes because you simply adding things together. Our first solution is already great for detecting single error. Let's introduce our second solution. It's called weighted sum. What does that mean is we times each digit a different weight based on their position in this case. Then add them all together. I'll just look at this formula here. After adding, we do say mode by 10. Why do we do that? The advantage introduce weight is we can identify error appeared at different position because the value at each position is amplified by different ways. Look, we have a 1, 9 and 9, 1. It's called transposition error. If mistake like this, simple sum wouldn't make any difference because you add them all together, it will be the same value. But if we apply weighted sum, you can see in this case 1 will be timed by 2 and plus 9 times by 3. Yeah, that makes 29. But this is for first case. And then the second case, if you had transposition error, that will be 9 times 2 plus 1 times 3. That makes 21. Therefore, we haven't introduced any actual digit. Just using 1 digit, we can achieve more than what we aimed for. We used to think about detect single error, but now we just lucky enough twist a little bit. We can also correct this commonly happened error, which is called transposition error. Unfortunately, we can't finish our story yet because the weighted sum has an issue. The issue is that after we introduce weighted sum, we lost some ability to identify single error. Have a look at these 2 cases. When we have single error occurred at position as a 2 or 5, let's see what happened. If we have a number transmitted mistake at position 2, so we change 1 to 6, right? Because weighted sum, we would calculate like at position 2 would be 1 times 2, right? Mode 10. That makes 2. It turned out 6 times 2, mode 10, is same, which means we can't identify mistake between 1 and 6 at position 2. Similarly, for position 5, we would have trouble when we have value 5 times 5, we know mod 10 is same as 5 times 7 mod 10, and same as 5 times 9 mod 10, because they all have same value. Why is that? Because 10 is not a prime. Once we have the factor of 10, then we lose some information. This is our final solution. We simply replace 10 by 11. We know 11 is a prime number. We will not have trouble of detecting single error. We can also detect all the possible transposition errors. So it's great. Let's summarize finally. Isbn number, his check digit is calculated by weighted sum and modular a prime number 11. The cost of modular 11 is we introduced a possibility having 10 as his check digit. And then we know 10 is no longer a single digit. The solution is to apply a Roman letter 10 to represent this real 10. That's why sometimes you can see a book number with a capital X at the end.